All right, we got one note card today. This is number 87, and the title is Polygons. And a polygon is a 2D figure with no curved sides and one inside area. A 2D figure with no curved sides and one inside area. All right, so what do you think about this? Does this have any curved sides? No, okay, so that's good, because it's supposed to have no curved sides. Does it have one inside area? Yeah, so that's good. So this is a polygon, because it has no curved sides, and it has one inside area. So, good, that's a polygon. Does this have one inside area? Yes. Does it have curved sides? Yes. Oh, so that's bad, right? It's good that it has one inside area, but it's bad that it has a curved side. So that's not a polygon. Okay, here's a four-sided figure. Doesn't have any curved sides, has one inside area. So that's good. And then this one. That one's out because it has two inside areas. All right, so polygon has to have no curved sides and one inside area. And we've been working with polygons most of the year, actually. We just haven't been calling it a polygon. So a triangle is a polygon with three sides. So when we were doing our we had 2 chapters, I think, on triangles. When we were doing our chapters on triangles, we were actually dealing with polygons. We just didn't use that word. And then if a polygon has 4 sides, it's called a quadrilateral. So we had an entire chapter on quadrilaterals. So we were talking about polygons when we did that. Some of the quadrilaterals were called parallelograms or rhombuses or rectangles or squares. All of those are polygons. And they just happen to have 4 sides, so they're called quadrilaterals. Okay, then if a polygon has 5 sides, it's called a pentagon. And if it has 6 sides, it's called a hexagon. If it's called a heptagon, then it has 7 sides. Heptagon. Then an octagon has 8 sides. A nonagon has 9 sides. I would think that a nonagon feels kind of insulted. Like if I called you a non-person, you would be insulted. This is a nonagon. I think it's probably it's a terrible joke, I know, but I think that'll help you remember that a 9-sided figure is called a nonagon. It makes it seem like it doesn't even exist. And then a decagon has 10 sides. Like a decade has 10 years. So a decagon has 10 sides. Then there's other names for other sided figures, but we're not going to, that's enough to. I think there's a special name for an 11-sided figure and 12-sided figure, but we're not going to put those down. So they're all polygons. All of these are polygons because they have straight sides and just one inside area. All right, next piece of information is we're going to have the formula for the sum of the measures of the interior angles of a polygon. So the formula I'm about to write down is the formula for the sum of the measures of the interior angles of a polygon. So, for example, it could be a pentagon, a 5-sided figure. And when I'm talking about the interior angles, I'm talking about these. So those 5 angles. And the formula I'm about to show you is a way of figuring out how much those angles add up to. So if you have 5 inside angles, it'll tell you what all 5 of them add up to. It's the sum of the measures of the interior angles. Okay, so now that you know what the formula is going to tell you, here's what it is. It's S equals 180, and then parentheses n minus 2. So if you wanted to know how much those 5 angles added up to in this pentagon, you just put a 5 in for the n. 5 minus 2 is 3. And then 180 times 3 is whatever it is, doesn't matter. But that tells you how much those 5 angles would add up to. Put a 5 here, and then it'll output that. Okay, now separately, we already know how much the angles of a triangle add up. What do the angles of a triangle add up to? 180, right? The 3 angles of a triangle add up to 180. We just have that memorized. But if you wanted to use this formula to figure that out, you could put a 3 in for the n, because n stands for the number of sides. So if you did 3 minus 2, that comes out to 1. And then 180 times 1 is 180. So most of the people in the room, you have it memorized that the 3 angles of a triangle add up to 180. But if you forgot, then you could use this formula to figure that out. And then also, if you want to know how much an 8-sided figure, how much those angles add up to, then you put an 8 here. Okay, so that formula is there for you. Then there's angles outside. That angle there is called an exterior angle. So those 5 angles now, that one, that one, that one, that one, and that one, those are exterior angles. And the exterior angles add up to 360. No matter how many sides there are. the exterior angles add up to 360, no matter how many sides there are. So if there's 10 sides to the figure, if it's a decagon, then the 10 exterior angles are going to add up to 360. Or if it's a pentagon like this, then the 5 exterior angles are going to add up to 360. So the inside angles will add up to something different, depending on how many sides there are. And this is how you figure it out. But the exterior angles are going to always add up to 360. All right, last vocabulary word for today. This is a regular polygon. A regular polygon is a polygon that has all sides congruent and all angles congruent. A regular polygon has all sides congruent and all angles congruent. So let's say it was a quadrilateral. What would a regular quadrilateral be? Yeah, Taylor? A square, right? Because if it's a four-sided figure, then if all sides are congruent and all angles are congruent, then it's called a square. So a regular quadrilateral is called a square. What's a regular triangle called? So regular means all sides congruent, all angles congruent. If it's a triangle, and all of its sides are congruent and all of its angles are congruent, what's that called? Yeah. Equilateral triangle has all sides congruent and all angles congruent, right? So then there could be a pentagon that had all sides congruent and all angles congruent. That would look like this, I think. I don't know if I'm going to get it perfect here, but you get the idea. That's a little too tall, sorry. So all sides are congruent and all angles are congruent, so that's a regular pentagon. But then here's a pentagon that's not regular. Because on this pentagon, the sides are different. And probably the angles are different too. Okay, so a regular polygon has to be all sides congruent, all angles congruent. That's it for today's note card. Thank you for listening. Paper today is called Geometry 10-1. Title is Geometry 10-1, and we're going to start with number 1. It says, number 1 is talking about a tengon. That means it's a polygon that has 10 sides. What's the name of a polygon that has 10 sides? Decagon. Good. So this number 1 could have written down decagon, and they would have been saying the same thing as a tengon. All right, so number 1 is talking about a polygon that has 10 sides. And the question is, what do the interior angles add up to? So we've got a decagon, and it's asking, okay, on a decagon, what do the interior angles add up to? So how can we figure that out?
S equals 1/8 parentheses n minus 2.
Yeah, so use this formula, right? This formula tells you how much the interior angles add up to. So it's 180. And this time the n is going to be 10, because n stands for how many sides there are. And 10 minus 2 is 8. And then 180 times 8 comes out to 1,440. So what this means is if you have a 10-sided figure, the 10 angles inside are going to add up to 1,440. Okay, I'm going to skip to number 4. Number 4 gives you another number. It's 1,080. And the question is saying there's a polygon where the inside angles add up to 1,080. And the question is, how many sides does the polygon have? So the inside angles add up to 1,080, and they want to know how many sides does it have. So how can you figure that out? Yeah. So we're going to use the same formula, right? This is the formula that gives you how many degrees the angles are. But instead of putting the number here, because we don't know the number of sides, so that's what we're trying to figure out, we're going to put the number here, because that's the s. So it's going to say 1,080 equals 180 times n minus 2. So now we got to work backwards to figure out what the n is. Now Judah's exactly right. This is a multiplication sign, right? So to get rid of multiplication, we have to divide. So we're dividing by 180 on both sides to get rid of that multiplication sign. So then you cross that out. So you take 1,080 divided by 180. I think that comes out to 6. Then what? Add 2, right? To get rid of minus 2, you just add 2. So this means that if the octagon has 8 sides, it's called an octagon because it has 8 sides. This means that if a figure has 8 sides, if it's an octagon, then the angles inside are going to add up to 1,080. All right. Next, number 5. The number given in number 5 is 9. And the question is, a figure has 9 sides, so it's a nonagon, and it's regular. And then it wants to know, first of all, for part A, what do the exterior angles add up to? So this figure has 9 sides. What are the exterior angles going to add up to? Yeah, Kieran? 360, good. Because there's no reason to use a formula on this one because the exterior angles add up to 360 no matter how many sides there are. So that was easier than when you're finding the interior angles. Okay, but then part B says, if the nonagon was regular, what would the measure of each angle be? So they all add up to 360, right? And if they're all the same, you just have to divide by 9. Because if it's a regular nonagon, that means all the angles are the same, so that's why I'm able to divide by 9. Now, if it wasn't regular, they wouldn't all necessarily be 40. But on this particular one, it said in the directions that it's regular, so that's why they're all 40. And then all 9 of the 40s would add up to 360. Okay, the last 2 example problems have pictures in them. You don't need to draw the pictures. Here is the picture for number 7. This angle is 70, this angle is 70, this angle is 56, this angle is 56, this angle is 64, that angle is 64. Okay, so the question just says, here's a picture, what's wrong with the picture? Sounds like a question rather than an answer. But Jude is on the right track, right? He's saying, why don't we add up the angles? And is this an interior angle or an exterior angle? Exterior, right? Because it's outside the figure. Okay, so we're going to add up the exterior angles. So I'm not sure what that adds up to, but hopefully somebody's figuring it out. Yes, sir. Thank you. No, you're good. So is it 380? Is that what you got too, Kieran? All right, thank you. So the exterior angles add up to 380. So that's not good, right? Because apparently, according to this fact, and we're taking it as fact, the exterior angles are supposed to add up to 360 no matter what. So what's wrong is the exterior angles do not add up to 360. Oops. Here's a picture for number 8, if I can draw it correctly. It's an octagon, and all the angles are marked as 135. And this side is equal to this side. This side is equal to that side. This side is equal to that side. And this side is equal to that side. So there's an octagon. Is this octagon regular? All the angles are the same, right? So doesn't that make it regular? No. All the angles and all the sides have to be the same for it to be regular. So this is meeting one of the criteria, right? All the angles are the same. But some of the sides are different, so that means it's not regular. Thank you very much, I appreciate it. Okay, so this is not regular, but that's okay. It doesn't have to be regular. I mean, is it okay that the angles are equal and the sides are not equal? Is that possible? On this figure, are the angles equal? Yeah, they're all 90, right? Are the sides equal? No. Okay, so it's okay to have a figure that has equal angles without equal sides. A rectangle is one figure that does that. So here's another figure that has equal angles but not equal sides. That's okay. Are the angles adding up to what they're supposed to? Why not?
Because it's much bigger than 360. Like that. Like all the 135 that.
Okay, so you are making a good point. 135 times 8 is bigger than 360. He's definitely right about that. What is 135 times 8?
1080.
Okay. So something good that Ethan is saying is that 135 times 8 is bigger than 360. And so that means these angles are bigger than, adding up to more than 360. Are they supposed to add up to 360? No, they're not. So the thing that you were missing was these are interior angles. And the exterior ones, the ones on the outside, they're supposed to add up to 360. But the interior ones are not supposed to add up. So good. What are the interior angles supposed to add up to?
1080.
Yeah, how do you know on an octagon it's supposed to be 1080?
That's question number 4.
Yeah, because our question number 4, we figured out that when you have an octagon, it's 1080. Okay, so this is adding up to what it's supposed to add up to. Okay, so it turns out that on this problem there's nothing wrong. Sorry about that. I wanted to point out 2 things. Number 1, it's okay to have equal angles but not equal sides. And number 2, just to remind you about the difference between interior angles and exterior angles.